Welcome back to part 3 of Equations and Proportional Relationships, Chapter 1, Section 5. We are on the last 2 slides, hitting the one that everybody loves so much, the apply slide, which means that you're going to need to work several things. First off, you need to do the what's your task part, which says you got to read that question 3 times. As you're reading it, work on these 3 things. You're going to have to write down how you're going to approach your task, and then you're going to have to write down your solution, which means you're going to need some big kid, high quality supporting work to get to your answer. Finally, you're going to have to write down in words how you can defend your solution. So, going up here, I got your problems showing. You all pause the recording, get this done, and then check your work. Hugo can run 4 miles in 25 minutes. How many more miles can Hugo run in 90 minutes than he can 25 minutes? Assume the relationship is proportional and he runs at a constant rate. I'm saying to run the same exact speed for 90 minutes, that's one tough dude. So, moving down, I have gone through this part, I've read it 3 times, I've come up with everything I need to know, and then I came up with a plan to solve the problem. My plan was that first I'm going to use a direct variation equation, which is the y equals kx, to find the constant of variation, which will be how far Hugo can run in 1 minute. Then I will plug that value back into that same direct variation equation and multiply it by 90 to find out how far he runs in 90 minutes. Finally, I'm going to subtract how far he ran in 90 minutes and how far he ran in the 25 minutes. I'm going to find the difference of those 2 numbers, and that will be the answer to my final question. So, let's go work on that. Starting off, I have my formula, y is equal to kx, where the total distance is going to be, hold on, actually I'm going to work this one, hold on, no, we're good, we'll work just like I said. So my y value is going to be 4, my k value is what we're looking for, and the time is going to be 25. We're going to isolate our variable by dividing 25 on both sides, just like we've done on all the others. 25 divided by 25 is 1. 1 times k is k. And then 4 divided by 25, if you were to take and do some long division on that one, we'll do it over here. 4 divided by 25. 25 goes into 4 0 times. Annexing your decimal and your 0. It goes into 40 1 times, which is 25 with 15 left over. Annexing another 0, it goes into 150 6 times, which is 150 with nothing left over. So my constant of variation is 0.16. That's how far Hugo can run in 1 minute, but that's not what the question asked. Now we're going to use that and our direct variation equation to write a new one, y is equal to 0.16 times x, where now my x value is going to equal to 90. Whoops, 16 times 90. And when I multiply that out, I'm going to take and put my 90 on top, my 0.16 on the bottom, just because I wanted to do it that way. And I can take 6 times 0, 0, 6 times 9, that is going to be 54. 1 times 0, 0, 1 times 9 is 9, add those up, and I end up getting, bounce, 19.40 miles. So my y value now is going to be 19.4 miles that he would run in that 90 minutes. But that's not the answer to the question either. They wanted to know what's the difference. So we're going to take the 19.4, subtract from it the 4.0 miles he ran in 25 minutes, and with that we're going to find that he would run a difference of 15.4 miles, which is going to be our final answer. So going back to our course, we're going to take, what is my solution? My solution was 15.4, and hit my check answer. What did I do wrong? Hold on. I found my issue. I did a little bit of a math boo-boo over here. If you take a look, I ended up with a, let's get my pin here. I ended up with a 9 right there. That 9 should be a 4, so I'm going to erase that 4 right here. And I'm going to erase 9 right there and 9 right there. And erase my 5 right there. I'll put in my 4 here, my 4 here, and that's going to make this 10.4. Now let's try and check that answer again and see if we do any better. So 10.4 miles, that does make a little more sense. Check it, and hoo-ah, we did good. I have explained my answer as I've done it, so I don't need to type this in, but you certainly do. Now, can you assume that Hugo runs at a constant rate for any amount of time predicted? Explain your reasoning. In the real world? Nah, I don't think so. I mean, 24 hours. You going to run the same exact speed for 24 hours? No, I don't think that's going to happen. That just doesn't make sense to me. Does it make sense to you? And with that, we are on the final slide. I want you to pause the recording, read the question, solve it, and I'll show you how I solve it in just a minute. Did you find an answer? On average, Ray answers 12 out of 18 answers correctly in a trivia game. Assuming the situation is proportional, how many more questions is he likely to answer correctly if there's 45 questions than if there was 18 questions? This one's very similar to the last problem we did. So, first thing we need to do, using our big kid math, write our direct variation formula, y equals kx. Now we're going to put in our pieces parts here that says that remember you got it, y over x, so 12 out of 18, y is going to be the 12, k is going to be what we're looking for, 18 is going to be our x value. From there, we're going to take and divide both of these by the 18. And when we do that, 18 divided by 18 is 1. 1 times k is k. And then 12 divided by 18, well, if I did that as a decimal, it would give me a repeating decimal of 0.66666. We don't like that. So instead, let's just simplify it. I could take 12 over 18, divide by 6 over 6, and that's going to give me 2 over 3, and the 6's came from the fact that that's the biggest number that would divide into both the 12 and the 18. So my constant of variation is going to be 2 over 3. And I think the dog and the goose are now fussing at each other outside. I don't know if you can hear them or not. From there, I'm going to go back and I'm going to put that 2/3 in for the constant of variation. Y is equal to 2 over 3 times x, where y is now going to equal to, well, I have 2/3 of 45 questions. If you remember when we multiplied fractions, we can take and simplify first. 3 goes into 3 1 times, 3 goes into 45 15 times, and now I can say y is equal to 2 times 15 is 15, 1 times 1 is 1, so our y value is going to be 15. So out of, I'm sorry, not 15. I totally got lost in my thoughts there listening to the dog bark at the goose. That would end up being 30 over 1, also known as 30. So we could expect that Ray would answer 30 out of 45 questions correctly, but that is not the final answer. It wanted to know how many more, or what's the difference in the questions that she would be able to get. So how many more questions is she likely to answer correctly if there's 45 than if there was 18? Well, in 45 questions, she was likely to answer 30 correctly. In 18 questions, she was likely to answer 12 correctly. And when you subtract those, of course, you're going to need to do some borrowing there. You're going to get an 8 and a 1. The answer we're looking for is going to be 18. So we're going to take and plug in our 18. We're going to check our answer, and we have won. Now, once again, I've given y'all some great examples of really good quality supporting work. This is what I must see. If I don't see y equals kx, if I don't see isolating the variables, if I don't see all this supporting work, you're not going to get all your points for doing your homework. Do it right the first time so you don't have to do it twice. Y'all have a good night.